Have you heard about this? Something just happened that could change how we build intelligence. A team scanned a real fruit fly brain, every neuron, every connection. They uploaded that map into a computer, and the fly just started walking. No training, no programming, no instructions. It woke up and knew what to do, just from the wiring. This isn't a small step. It might be a new path to AGI. Not a smarter chatbot or a better image generator, but copying biology itself. The main player is a company called AGI Systems, co-founded by physicist Alex Wisner, Harvard, MIT. This isn't a typical AI shop. It blends compute with brain mapping. In 2024, scientists finished a complete fruit fly connectome. AGI didn't just study the map, they ran it. They treated the brain's blueprint like software, loaded it into a powerful simulation, and let it run free. The digital brain was wired to a realistic virtual fly body, inside a physics engine called MuJoCo, using a body system known as NeuromechFly, a real brain map driving a realistic virtual body in a realistic world. The behavior wasn't random, it looked like a fly being a fly. A connectome is a complete wiring map of a brain. Think of it like an ultra-detailed circuit diagram. It shows where neurons are and every single connection between them. The fruit fly connectome was published in 2024, about 125,000 neurons, and 50 million connections. Built from thousands of ultra-thin slices scanned at high resolution. Then, machine learning traced every neuron through all those slices. The result, a 3D blueprint you can load into a computer. So how do you go from a dead fly's brain to a walking virtual creature? Step 1. Get the map. Slice the brain, scan every layer, rebuild it into a precise 3D picture. Step 2. Interpret the map. Figure out which neurons excite and which inhibit. Estimate connection strengths across the network. They report about 91% accuracy. Step 3. Build the body. A realistic virtual body with gravity, friction, and joints. Sensors tell the brain when a foot touches the ground. Step 4. Connect brain and body. Sense, think, act. Over and over, thousands of times per second. Out of a copy, behavior emerges. Most AI you use, ChatGPT, Gemini, Claude, learns from data. We feed them the internet. They find patterns. They predict what comes next. Reinforcement learning tries, fails, and tries again. It finds efficient motions, not necessarily natural ones. Here's the split. Learning an intelligence versus copying one. AGI didn't train anything. They copied the brain's wiring. Imitation is one path. Emulation is another. While NVIDIA powers today's AI with GPUs, Google's Gemini pushes learning-based models. Microsoft backs huge model training with OpenAI and beyond. OpenAI, xAI with Grok, Anthropic, all scaling learning systems. This is a different philosophy. Modern AI builds tools that act intelligent. This recreates the thing that produces the intelligence. As one comment put it, we stole the weights and ran inference. It's the jump from imitation to the underlying principles, or like putting a bird's brain into a plane and letting it fly. This points to a second track toward AGI, whole brain emulation. You could call it copied, or emulated, intelligence. Let's hit the brakes and be real. The simulation today is just wiring. Real brains run on chemistry too. Mood, motivation, learning. Half the brain cells are glia, and they're ignored here. That's like modeling a city without roads, power, or water. The connectome is a snapshot. It can't learn or adapt. Neural plasticity, a core of intelligence, isn't there yet. Claims like 91% accuracy need rigorous testing. And remember, announcements can have financial incentives. Even so, the fly's behavior looks real, not random, impressive, but early. The big missing pieces, chemistry, glia, and learning. This stands on decades of work like OpenWorm, just 302 neurons. The results were basic, but it proved the idea. Then Flywire mapped the adult fruit fly, a 400x jump in neurons, from a few thousand links to 50 million. Others trained flies by reinforcement learning. AGI plugged the real wiring into a body. No training. It's the difference between learning to fly and being born with wings. Now, the big question, can this scale? A mouse brain has about 70 million neurons. That's a 560-fold jump from the fly. Some say it's an engineering problem more than a science one. But humans? Roughly 86 billion neurons, hundreds of trillions of connections. The data needs are mind-bending today. Yet compute keeps growing with new chips built for brain-scale sims. Scanning tech is improving fast, even expanding tissue to see more, and imaging methods to watch activity live are advancing. Impossible today doesn't mean impossible forever. Right now, we're at a fork in the road. We're a long way from uploading a human mind. The gap from fly to human is huge, but this proves something big. Copy the structure well, and real behavior emerges, like the Wright brothers, short, clumsy, but historic. Now comes ethics. Who owns a copied mind? What rights would it have? We should watch with excitement and a critical eye. We've tried to build minds from scratch, but what if the fastest way is to copy?